Okay, so in this video series, we're going to be proving cross-product properties. We also have a series for proving dot product properties as well. But in this very first episode, we're going to take a look at kind of the most basic one, but pretty interesting property, that A cross B equals negative B cross A. So basically saying that unlike the dot product, the order matters. So we're going to first split up A and B into their own components. And since we're working in R3, we can split it up into like X, Y, and Z components. So the first thing we're going to do is we're going to remember that what the cross product is, kind of the formula, is A2B3 minus A3B2, A3B1 minus A1B3, and then A1B2 minus A2B1, right? So this corresponds to some I. This might be a little bit more familiar. And then we're going to have A1, A2, A3, B1, B2, B3. So some of you guys might have seen it by like taking something with determinants or whatever, but this is a pretty simple way of doing it. So the first thing we're going to do is A cross B, so it's this thing corresponds to the A here, and then this thing corresponds to the B here. So let's just give us some more space. So let's just take the cross product. So A2 times B3, well, honestly, it's just going to look just like this, so we can safely write it like this. So I'm just rewriting this down here exactly. Okay, and we're told that this has to equal the cross product of the negative cross product of B and A. So this is going to be a little confusing, so I apologize for writing it like this, but now B corresponds to this top-ish column, and A corresponds to this bottom-ish row, row. So we're going to do B cross A. So A2, B3 corresponds to B2, A3 minus A3, B2 is B3, A2. A3, B1 is B3, A1. And then A1, B3 is B1, A3. Finally, A1, B2 is B1, A2. And then A2, B3 corresponds to B2, A1. Okay, and just so before we move on, this is just like a general form right here, what I've circled. This is a general form of the cross product. It might have been a little bit confusing that I used A and B here and here, but like that doesn't really matter. This is just the general form. So you take A to be like the first thing that you're crossing, and then B to be the second thing you're crossing. So in this example here, in this part where we did B cross A, B happened to be the first thing we crossed, so we put it effectively in this column. So we let B1 equal A1, B2 equal A2 just for this case. So that's how we got to this thing at the bottom. So now let's give ourselves some space. Okay. The left side, there's not much that we can do. So I'm just going to rewrite this down here. But on the right side, we have this weird negative that's just kind of like chilling. So what we're going to do is we're going to have to end up actually distributing this negative to everything. It's a bit of a annoying thing. But as we distribute it, we're going to get, let's just rewrite this as B3A2 minus B2A3, and then minus B3A1. This will be positive minus B1A2. And now, just taking a look at this, we remember that the order doesn't matter when you're doing multiplication. So we can pretty much just safely rewrite the right side. So right here, let me just copy this left side down, not changing absolutely anything. And we can say that this is effectively equal to, since the order doesn't matter, B3 times A2 is the same thing as A2 times B3. So let me just rewrite this as that. B1 times A3 is just A3 times B1 minus A1 times B3, A1 B2 minus A2 B1. So the left and right side equations are equivalent, so then therefore we can do a little check mark. A cross B equals negative A, oops, equals negative B cross A. These are all vectors. Okay, I hope I helped. Thanks for watching.